In this lecture, we will learn principles for making informative data graphics. These principles were introduced by Edward Tufte in 2006. Tufte is known for his groundbreaking work in information design, the study of methods to simplify the learning of all types of information, and more specifically, data visualization, which focuses on visual methods. What are the fundamental goals of our graphs and charts? Tufte suggested we present evidence to assist our thinking process. Visual analytics enables human information discourse, and these principles are universal, that they are independent on technology. Principle number 1, comparison. Showing comparison is the basis of any scientific exploration. We ask question, compared to what, when we present evidence to our hypothesis. Plot on the left shows a clinical trial testing for air cleaner to improve asthma-related symptoms. In this case, a higher number is better, more symptom-free days. From the plot, however, we do not know what happened when the air cleaner is not used. Plot on the right shows the comparison between the control group, no air cleaner, and the treatment group. And here we can see that on average, the control group children changed very little in terms of their symptom-free days. Therefore, we can say, compared to children who did not receive an air cleaner, children receiving an air cleaner experienced improved conditions. Note that the essential point is to make intelligent comparison. So not every comparison will turn out to be meaningful. We can use a variety of comparison objects, time comparison, comparison of different components, and comparison between different groups. Principle number 2, causality. This is the core principle behind data visualization. We need to explain, provide links between cause and effect, show causality, mechanism, explanation, systematic structure. Generally, it is difficult to prove that one event causes another event. However, it is useful to show your causal framework about the questions that you're asking. It may even help you raise new questions. The follow-up on the previous comparison chart for asthma-related air cleaners can be, why do the children with the air cleaner improve their conditions? The hypothesis behind is that air cleaners remove airborne particles from the air. And the plot on the right shows the change in fine particles in the air with and without air cleaners. Principle number 3, multivariate data. The real world is multivariate, and there are usually many attributes that we can measure. The point is that data graphics should attempt to show this information as much as possible. We retain as many features as are necessary to maintain the desired explanatory power. Let's look at the figure demonstrating data on daily airborne particle matter in New York City and mortality from 1987 to 2000. The bivariate plot shows a negative relation. The higher is the level of particles, the lower is the mortality. However, it is well known that mortality tends to be higher in the winter than in the summer. So the panel, a set of plots on the right, illustrate the effect of the season. A season is related to both particle level and mortality counts in different ways for each other. Principle number 4, integration of evidence. The main argument is that evidence from data is better understood when it is presented with context and accompanying metadata. Data graphics should make use of many modes of data presentation simultaneously and integrate as much evidence as possible into graphics. So when authors and researchers select just a single specific method during the inquiries, the focus switches from can we explain what is happening to can the method we selected explain what is happening. So Tufte makes the point that we should think of data visualization and data tables as elements that provide vital evidence, and as such, they should be integrated in the body of text. Tables of data might be thought of as paragraphs of numbers tightly integrated with the text for convenience of reading rather than segregated at the back of report. Document the evidence. Data graphics should be appropriately documented with labels, scales, and sources. A general rule is that a data graphic should tell a complete story all by itself. You should not have to refer to extra text or descriptions when interpreting a plot, if possible. Remember, the credibility of evidence depends significantly on the quality and integrity of the authors and their data sources. The plot on the left is the default plot generated by the plot function in R. The plot on the right uses the same plot function but adds annotations such as title, axis labels, also key information included, where data is collected, the units of measurements, the time scale, and the source of data. Depending on the context, questions and items to address could include: what is the title of the visualization? Who did the analysis? Where did the underlying data come from? What assumptions were made during data processing and cleanup? And what color schemes and legends and scales are in use in the chart? Principle number 6, content. Analytical presentations ultimately stand or fall depending on the quality, relevance, and integrity of their content. Starting with the good question, developing a sound approach, and only presenting information that is necessary for answering that question is essential for every data graphic. And the most effective way to improve presentation is just to get better content. Remember, content is the king.